So, welcome, Daniel.
Thank you. Welcome from my side. So I'm talking today about automating DNSSEC, specifically using CDS or CDNS key. So what it is, we will see in shortly. Yeah, it works. So DNS quick recap protects you from spoof DNS answers. DNS is also the foundation to various other security controls. For example, you can store CAA records in DNS to limit what certificate authorities can issue certificates for your domain names, or you have email spoofing protections which you can add to DNS like SPF or DMARC. So all these security controls, you can protect them with DNSSEC. This talk is not an introduction about DNSSEC. So if something I will tell later on is just too complicated, I have to refer you to the URL below. There is a short explanation how DNSSEC works. We will cover some basic aspects, but it's not, we are not going into crypto or really protocol details here. So, and you also see from the graph, .ch or .li got signed in 2010. For many years it was quite time, and now the curve is slowly ramping up. Some hosting companies have started, when you register a domain name, typically you get DNSSEC is enabled automatically. Maybe you're even getting a TLS certificate by default. So this is what I would like to see in other places as well. Let's look at how do you register a domain name today. So the registrant is typically the domain owner, and you go to a registrar where you can register .ch domain names. So there are over 100 such registrars. Some of the bigger names like Hostpoint, Metanet, Switch Plus, and so on. You register your domain name and through your registrar, and the registrar has a direct interface to the registry system. That's for .ch it's Switch. So that's how the information flow is. Now imagine that you also, in the end when you have your domain name, you need to configure it at some place on a DNS name server. If your registrar is also your hosting provider and web hosting provider, that means you don't need to instruct the DNS operator because the registrar and name server operator is the same person. So in that case, what I'm talking about here, it's not relevant for you because your registrar and hoster can already automate DNSSEC fully. But this talk is about if your name server operator is someone else than where you registered the domain name. So let's say it's Cloudflare, a typical example, or there are other DNS hosters, or maybe an enterprise company. You host your DNS yourself. You manage it yourself. So you instruct your internal IT to configure this domain name on the name servers. When you want to sign the zone, so this is just a symbol here, I'm going back, so you sign it, you create a public-private key, sign the zone, and now you need to add the public key to the parent zone. It's actually a digest of your public key to the parent zone, so there is a chain of trust. The old way, which is valid for all the TLD extensions, is that the registrant needs to add this information through the registrar interface into the registry. And you can see from this picture, if the name server operator is not the same person as the registrar, you cannot really automate it very well. Some registrars may provide APIs, others don't. Some don't even have an interface where you can add DNSSEC information. For some you have to write emails, for others you so it's in the end it's complicated, and even within a company, and even if your registrar would support DNSSEC, it's also possible that maybe the registrant is your marketing guy. Nothing about marketing, but maybe they don't understand your instructions correctly. So copy paste, they're making errors, they're leaving a field, and then it breaks your domain. So that's one of the problems we have today. And so people are afraid of securing DNS with DNSSEC because of this manual step. So what is the new way we provide, .ch and .li provides to add DNSSEC, the trust anchors to the parent zone? The new way is we are going to scan all the .ch domain names and check if you publish a specific record. It's called the CDS record in your zone, where you signal that you would like to have that particular key added to the parent zone. So what is the motivation? The motivation is allow domain operators to automate DNSSEC. Not only bootstrapping DNSSEC, but also do key rollovers. Then providing a simple method to enable DNSSEC, so no more email writing, login, and so on. If you can automate it, you're making less errors. So automation kills errors, and it actually shows how easy DNSSEC can be. I have added a note here. If you would use this new method, so you publish in your zone a CDS record, and we are scanning for it, and if we detect it, it could mean that your zone is bootstrapped and is now DNSSEC protected, but in fact your registrar is not supporting DNSSEC at all. So you have no control to disable it manually. And I personally would say, for emergencies, you may never know they happen, it's good to have an automatic manual interface through a registrar where you can do manual changes. Automation is this process is for automation. It's not to avoid your registrar. So this is a configuration example for KNOT. KNOT is DNS authoritative name server. It's an open source. The URL for the software is given below. So this is a basic configuration. I skipped some part about on which interface to listen on, but that's basically what you have in the configuration of KNOT name server when you have for all your domain names. So you have a zone domain example.ch, and this example.ch zone file is stored in the default template. I didn't have to reference it because it's a default template. So the storage for the plain text file is below the path var lib knot. So that's the case for now. And now you would say, I want to DNSSEC sign the domain. You add that line. And what will it do? It signs your domain using a crypto algorithm. In this case, the default by KNOT is ECDSA. It's using a split key schema. There's some details. So it has a KSK and zone signing key. The KSK has a lifetime of 0, which means infinite. It's never rolled automatically. And there's a second key, zone signing key, which is rolled every month, more or less. And what is important, CDNS key publication is always. It means when you add this line, you are already signaling the CDNS key in your zone. So that's something which we will pick up, and that means this domain name would now be bootstrapped and secured automatically. So that's all. DNSSEC can be that easy. But now let's talk about how does this protocol actually work, this CDS scanning. So we implemented through two RFCs which specify how one should do it, and we were so we tried to implement it as close to the RFC as possible. The reason is, of course, that when you have multiple TLD domain names, you want it that this mechanism is working for every TLD extension the same. So how do we get the CDS data for your zone? There are two use cases. One is your zone is already secured. You already have a trust anchor at .ch. In that case, we don't need to scan it directly. We don't need to ask your authoritative name server with our software. We can just ask a validating DNSSEC validating resolver, normal query, give me the CDS record for that zone. Because there is a chain of trust, it can be validated. In that case, we check for 3 days, the result must stay the same. That's to avoid if you do some testing, maybe you enable something, you change something. So we want the result should be the same for 3 days, and then it gets executed. The other use case is when your zone or domain name is not secured with DNSSEC. In that case, we will not just do a DNS lookup on a validating resolver because it doesn't provide any security because your zone is not DNSSEC protected. In that case, so we will scan all your IP addresses which are authoritative for this domain name. We connect through TCP. That's just UDP is more easily to spoof, so we connect through TCP. And all these name server addresses need to provide the same answer. If that's not the case, we will not bootstrap you. And we check it from multiple vantage points. So it's not just one server at, let's say, a switch network. There are multiple servers doing that. And then the fifth rule is the same. The result needs to be consistent for 3 days. And then we will bootstrap your domain automatically. The second step is when we have the result, it's consistent, has been consistent for 3 days, we also validate it. So we only accept your CDS record if it does not break your domain name. Let's say you signal CDS, but you haven't actually signed it with that key, then we will not accept it. Or if it doesn't matter if your domain is already signed or it's not signed. So if the publication doesn't make sense because it would break your domain, we will not accept it. And some technical details, what kind of DNSSEC algorithms we support at the moment. I've just listed them here. I think I don't need to talk about the crypto at the moment. Some additional information. So the CDS, so if you were to manually go to a registrar web interface and change something with the DNSSEC information at the registrar interface, this will always overwrite what's in the database at switch. In that, if you have, let's say you have published CDS records for your zone, and it has been the same for 2 days, and then you change it manually, then the counter for the CDS scanning is reset to 0. Whatever you provide through the registrar is always taken. Then the domain name, when you register the domain name through a registrar, the registrar may have a local copy of the information for that domain name, and it doesn't rely on permanent connectivity to the database at the registry. To avoid that the registrar has outdated information, we send the registrar a poll message that there is an update for the domain name. It shouldn't interest you, but that's just for your information. So we thought that the third part is more important. We thought about, should we contact the domain owner that we have bootstrapped the domain with DNSSEC, or like sending an email? And we have decided to not do it. there are multiple reasons. I think one is we think we will likely email the wrong person. That's one of the most reasons. I know that there's another CCTLD supporting this mechanism already. They at the moment send emails, but I've heard they may stop with that because most of the time the email is not getting to the DNS operator at all, so it's not useful to the person who receives it. And the other reason is we implemented this to provide automation, and email and automation doesn't really sound like 2018. However, we provide a status portal. So this URL you see below, I have some screenshots for that. When you go there, you see a portal, a web page, where you can enter any domain name, any .ch or .li domain name, and it will show you what's the current status for, have you detected that you publish a CDS record? Is the CDS record already accepted, and so on. So this is a screenshot of one of our test domains, which is in the state pending. There is the domain name, the state pending, as I said. Then we say the expected processing date will be on the 12th of October. Type of change, it's bootstrap, so it's unsigned at the moment. But you signal that you want to add the trust anchor to the parent zone, so it's bootstrap. The last scan run we did was, when I took this screenshot, was on the 9th of October. And so scan runs, there was one scan run, and it needs 3 in total. So that means like, on the 12th of October it would be in the database. So this is just information for the operator to see how long does it take and so on. At the moment, we are thinking about also providing an API for that interface, but it's not done yet. So who is using it already? So we scanned .ch and we saw that 900 domain names already publish a CDS record. You may say that's a very low number, but on the other hand, this protocol is very, very new. So if you want to enable that, you have to use a DNS name server software, which is quite new. So something like, mostly, I'm not sorry for appliances, but mostly appliances are a little bit out of date, so you will likely not be able to use CDS for the next 2-3 years at least, I guess. With open source software, if you install the package from the vendor, open source vendor directly, then you have support for this mechanism. So having said that, I think 900 domain names already publishing CDS records not that bad. So what kind of 900 domain names are publishing CDS records? So we looked at the registrars. That doesn't make any sense, completely stupid, because it's not the registrars which publish it, it's the domain DNS operator. But still, just to give you some ideas, it's a completely random statistic, could be anything else. I wondered why Gandhi is here on the top, because it's not a very large registrar for .ch, but it tends to attract a lot of nerdy operators or domain users. More interesting is the statistics on the right. What kind of DNS operators are publishing? So that's the name server operators are publishing CDS records. And you see Cloudflare is one of the top, Google domains, and there is another CH hosting. The list is that the total of the 3 on the right is not 900, but the others I omitted because if it's only 2 or 3 or 5, it's not telling anything. So, I'm coming to the almost last slide. So DNSSEC is easy as you have seen. So please sign your zone. Turn on DNSSEC validation on your resolver. And I usually like to tell, don't be on Team Telnet, because the old days, they are gone. With that, I would like to answer questions here. questions if you have some. There's also an FAQ on the switch.ch setup a website which goes into more details about the process, how it works in detail.
So when you're bootstrapping a new domain with a CDS that's not previously protected with DNSSEC, you're crawling it 3 times, I believe, to verify that there's no like hijacking going on, I guess. How many different vantage points and from which geographic locations are these vantage points when you're doing the verification?
So at the moment we have 2 geographically locations in across Europe. We may add more in the future, but for sure not less, but at the moment it's 2.
I am Claudius from NGWorks. This process for bootstrapping doesn't look 100% safe to me, like, yeah, for hijacking. You have some points to make it more secure, but it feels as hijacking is still very possible, very probable. So I wonder, what's the ratio of DNSSEC validated domains that you get from register versus you bootstrap?
So what? Can you repeat the last questions? What do you mean by the ratio from?
Can you compare the number of zones that you get registered via register? I mean, where you get the keys, the DNSSEC keys from a register, versus the bootstrapped ones.
Okay. So so CDS is enabled since the 9th of October, and until end of year, this is like a period where we enable CDS only for registrars which have told us that they have verified that they can accept our poll messages. So at the moment, if you want to use CDS until the end of year, after in 2009, you can use it for any with whatever domain registrar you used. But until end of the year, we only have at the moment the process is only enabled for 2 registrars, which already provided feedback that they can handle the poll message that we have changed their second-level domains. So that means the process is running for only a few days now, so there is not much data. I think the bootstrapping has happened for something like 100 domains so far. And then we have something like 80,000 domain names which are handled over directly by the registrar through that communication path. So it's, if that doesn't answers your question.
No, okay, so just a little. To me it looks like a very effective tool for hijacking domains.
So yeah, what do you think is the problem? Is it BGP hijacking, or?
For example, yeah.
So for BGP hijacking, you would need to hijack 2 geographic locations. You can find them out because we are scanning from these IP addresses. And then every time we scan your server, you need to provide a result set which will enable DNSSEC for your domain, but does not break it. We don't accept it if it breaks. We are not doing the validation after 3 days. We are doing the validation each time. So the message you send us needs to be hijacked, and then it's stored. So it needs to go from the scanning location. It goes to the validation point, and that's a time shift for, let's say, I don't know, 1 hour, 2 hours until it's validated in the backend, and then the backend does some validation, and for that it may contact your domain name again. So it's like, I would say it's probably not so easy. And even that, so what do you get if you bootstrap a domain with DNSSEC?
You kill the domain.
Yeah, but if you've been able to hijack multiple locations, trick our system for multiple days, and all you do is kill a domain, I think you probably hijack other stuff. It's like, I doubt we see a hijacking, but I agree, it's theoretically, it's not impossible. If there are some domain names who can be hijacked for multiple days without anyone noticing, fair enough.
Any more questions? Oh.
I, in principle, like very much like that you like focus on security and like improving the whole base infrastructure. However, there's like one open problem with DNSSEC, and I was wondering what your current opinion is to that. With NSEC 3, you are able to do zone enumeration. There's a proposed standard or alternative, NSEC 5. Last time I heard it's not so popular. What is your take on this? Like, because like whenever you switch to DNSSEC now, basically everybody knows how many domain entries you have.
So Switch does signs all their domains with NSEC, so we don't care if you enumerate our zones. I would switch to NSEC for .ch if we were allowed, but at the moment there are other reasons we are not allowed to. So .ch would like to publish the CH zone as well, but we can't do that at the moment. I think it's nonsense. If you have something to the internet and it's resolved, people have that information. It's mainly not everyone in this room has this information, but passive DNS has existed for more than 10 years. So if you ask me for your domain name, within 1 hour, I probably will be able to provide you with 80% or 90% of the records. So it's kind of seems to me, I'm actually quite happy that a lot of open source vendors, when you sign a domain name, they default to use NSEC, because I think NSEC 3 is a waste of time. It's making everything more complicated without providing a benefit. So I can also give you another example. Switch.ch has about 10,000 records. And for an experiment, I copied that zone, added it on a test server, and then I run nmap. It's a scanning tool. It can also enumerate all the NSEC 3 records. So it was able to enumerate all the NSEC 3 chain records within like 5 minutes. And then it was also the only difficulty, or the only challenge now is how good is the brute forcing. And hostname letters below 9 characters, it's like doesn't take more than 1 hour. So if you're using NSEC 3 and your typical hostname is less than 9 characters, doesn't provide you anything. It's like work for less than 1 hour. So I came to the conclusion there's no way around. If you do DNSSEC, or in general, if you do DNSSEC, it's in the public. There's no reason to try to hide it.
Fair enough, thanks.
Thank you very much.
Thank you very much.